Hello everyone, welcome to the mechanics class. Before we proceed, could you please confirm, are you able to hear me properly and see my screen? Yes, okay. Yeah, so then let's continue this session. As I mentioned before, in today's session, we are going to study the topics which were left or which we have decided to cover at the end of the syllabus, and they are like virtual work and Lagrange equation. Okay, and there is a reason for it. Um, and you'll understand why we kept it in there and not while studying the, so especially why we not studied virtual work while studying the statics part, and why we kept it at the end. Okay, and same for the Lagrange equation, we are keeping it in then, not covered during the uh, work energy principle or the kinetics part. Okay, um, so let's start with the heading. um, Virtual work. Write down heading virtual work. Okay, we'll first start with the virtual work and then we'll move towards the um, Lagrange equation. Okay, um, so till now, if you, okay, we got one question from Abhishek. How many classes are left here? So yeah, for all of you, we will be having one more class on Saturday. Okay, where we will study some problems. Okay, starting from statics, and if required in future, we can have a doubt clearing session as well. Okay, but as of now, we'll be having only one class, except apart from today's class. Okay, so that will be on Saturday. And we will use our WhatsApp group for our communications. If you feel any, I'll be sharing you questions regularly in that group. Okay, once or twice a week, so you can uh, you will be in touch with the subject, and you can freely share your doubts there, or you can directly approach me. Okay, as you feel comfortable. Write down heading virtual work. And as I know, like on Sunday, maybe they'll start a new subject for you. Um, so till now, if you remember, like the way we solve the problem is by using the equilibrium equation. Okay, so I'll say solving problems of statics problem. There are two ways to do it, either with the um, equilibrium equations. You know, equilibrium equation, summation of all forces equal to zero, summation of all moments equal to zero, right? Depending on direction, you will apply summation x, summation y, and all. And there is one more way, that is virtual work method. Okay, so it is not mandatory that the problem should be solved by virtual work only. Okay, and that is the reason we have not studied it when we were studying the statics problem. Generally, everyone prefers the equilibrium method, and it is commonly used uh, to solve the problems. Okay, but there is an alternative method. You should be aware of it, and you may not be using it in future, but it will be good that you are aware of this. So that is the reason um, we are studying it then. Okay, it's an optional, not necessarily um, required, you can still solve the problem with the equation of equilibrium. Okay, and we use it in statics mainly. So when body is in equilibrium, there is no displacement, we can say, to the body. Body is like at rest, and then we say it is in the equilibrium, and summation of all forces and moment equal to 0. But if we imagine a displacement, okay, so let's assume a displacement, let's call it as a virtual displacement. Virtual displacement maybe. Okay, what is the virtual displacement? You can denote it by delta theta or delta s, whatever you want. You can give the notation. Generally delta s, delta theta is used for, let's say, linear displacement and angular displacement. And this is virtual displacement is like arbitrary infinitesimally small change in the position of the particle. Okay, and consistent with the constraint imposed on it. So write down the definition of virtual displacement. Virtual displacement of particle is arbitrary infinitesimally small, very small, very small change in the position of the particle. Okay, consistent with the constraint imposed on the particle. Okay, so it's an imaginary displacement. In reality it is not happening. Okay, because body is in equilibrium, it is at rest, it is not moving. But in order to solve it, we are assuming like we are imagining that there will be a displacement of small displacement, let's say delta s, and that will help us to calculate work, because force into displacement is work, and it will help us to solve the problem. Okay, so like if we have let's say a body like this, and which is kept on a horizontal surface, and a force is applied F, or let's say P, and the body is, let's say, imaginary displacement is delta S, then work here will be F or P, sorry, P cos of theta. Okay, P cos of theta into delta S. Okay, delta S is an virtual displacement. Then this work, I'll say it as a virtual work. Okay, I hope you are getting it. Similarly, if we have, let's say, a beam and you are applying some moment over here, and because of this moment, let's say there is a small change in angle, that is delta theta, then moment because of, or work because of this moment is moment into theta, and in this case I'll call it as an virtual work. So what is virtual work? Virtual work is the work done in producing a virtual displacement. Work done in producing virtual displacement. Okay, so delta u, let's say virtual work, generally we denote it by delta u, and that is equal to F times delta S. Okay, and we know now what is virtual displacement, we know the force, and we also understood virtual work. But what is principle of virtual work? What is this principle says? So write down heading principle of virtual work. Write down heading principle of virtual work. If a single body, or if a single rigid body, or a system of rigid bodies is in equilibrium, then for any virtual displacement, for any virtual displacements with the constraints on the system, with the constraints on the system, the virtual work done on the system is zero. On the system is zero. Okay, so this is the statement of the principle of virtual work. Okay, so in short, total work done, total virtual work of external forces acting on the body is zero. Okay, or in other words, you can say constraint on the system means Abhishek, the mm, supports which you are giving. Okay, so you are, let's say, giving a fixed support at one end maybe, or let's say roller support at the other end, so you are keeping it same. Okay, it means your reaction will remain same, they will not change. So whatever let's say constraint means, I explained you, if you put the roller support, what does it mean? It is you're putting a constraint on the virtual vertical motion of this beam. Okay, if you are putting the um, let's say uh, pin joint, you are not just putting the constraint on the virtual vertical displacement but also on the horizontal displacement. Okay, and if you have the, let's say, fixed support, then you are not even putting the constraint on the vertical direction, also in the horizontal direction, and also on the moment. Okay, so constraint means whatever restrictions you have made in the problem before, they will remain unchanged. Is it clear? Is constraint is opposite of the freedom, degree of freedom. Yeah. So in other words, in simple words, the statement can be written as total virtual work of the of external forces, of external forces acting on the body is zero. Okay, for any virtual displacement of the body. Okay, so in this way also you can uh, write the statement. Okay, let's start with a simple understanding of it. So if I give you a block and if I ask you to apply the equilibrium equation to it. Okay, um, suppose if I put a block of weight W and ask you to calculate the reaction because of the ground in this, so what you will say, this block is at the rest, it is in equilibrium, so summation of all forces in vertical direction has to be zero. Ground will create an vertically upward reaction, that is N, and hence the N will be equal to the weight of the body. That's all you will say, right? You will, there is no need to do any complexity in this. But now, if you want to apply the principle of virtual work to this, how it will look like? So let's say this is the centroid, for example, G, and imagine that G is moved because of the weight to G dash, something like this. Okay, there is, let's say, change in the position in the vertical direction from G to G dash, and this position change is like delta Y, for example. Okay, delta S. So in y direction, we assume it as a delta Y. So what is work done because of this work done for this virtual displacement delta Y? Displacement is downward, weight is also acting downward, so it's a positive work, W into delta Y, minus force is up, reaction is upward, so N times delta Y is equal to 0. According to the um, principle of virtual work, this is the total work done because of the external forces acting on the body, and that has to be 0. That is why equal to 0 we are writing here. Is it clear till this? And now if you equate N delta Y is W delta Y is equal to N delta Y, and delta Y delta will get cancelled, and W is equal to N. Okay, so this is the way we can convert um, or we can still get the reaction if you don't want to use the equations of equilibrium. Okay, but ultimately it is same thing, right? Like, so generally everyone feels this is complicated or unnecessarily let's say an extra work um, we are doing by applying the principle of virtual work, and nobody uses it in mainly in real life, because the equations of equilibrium makes life a little bit easier than the virtual work concept. Okay, but still you should be aware of it. In some cases, if you need, you will be able to um, solve it. Okay, maybe in some theory questions in future. But for gate, they'll not specify anything that you have to solve the problem by virtual work or this. They just need the reactions, or they need the force. Then you will be able to calculate it just by equations of equilibrium. Okay. In the same way, if I give you another simple question, let's start with a simple question first, so that you will be aware of it, and then we will I'll bring a problem of beams to make the concept clear. Okay, for example, this is an L shape arm, and this point is A, this point is B, and this point is C, for example. Okay, so at point A we are applying 10 kilonewton of load, which is AB is 2-meter long arm, and BC is 1 meter. Okay, it's completely a single system ABC, and the C is supported by the roller support, so you will have one reaction here. Okay, let's call it as RC. B is supported with the hinge support, so here you will have two reactions, VB and HB. Okay, or let's say BX and BY. Okay, and they are asking you to calculate the RC. How will you calculate RC? You will say, if I take moment about point B, I'll get the value of RC. So it is very simple. 10 summation of all moments about point B is equal to 0. This is an equation of equilibrium you will apply. So you'll say 10 multiplied by 2 has to be equal to RC multiplied by 1. This implies RC is equal to 20. That's all. Within a few seconds, you will get the answer. But if I ask you to solve this by virtual work, how it will look like is like this. So imagine that you are turning this with an displacement delta theta. So something like this it will look. Okay. Delta theta displacement, and let's say this is the XC is the displacement here, and XA is the displacement over here. Okay, or this should be YC because this is in the Y direction. Okay, YC is the vertical displacement of point C, XA is the horizontal displacement of point A. So if I want to calculate the value of XA, how much it will be? XA is apply the logic here, that is R theta, you can say, for a small displacement. So it is 2 delta theta, I can say, and yc, I can say it as 1 times delta theta, right? And so now if you calculate the work done here, 10 is applying in rightward direction, but displacement is leftward, so it's negative work, minus 10 xa. Here RC is applied in the same direction as the rest of displacement, so it's a positive work done, RC into YC, that is equal to 0. Okay, and now if you put XA value, XA is 2 times delta theta plus RC times YC is 1 times delta theta equal to 0. You will get RC is equal, delta theta will it cancel, RC is equal to 20. Okay, in this way also you can find, but you can clearly see here, compared to equation of equilibrium, this is bit complicated or takes little more time, I would say, rather than saying it as complicated. Okay, so yeah, but this is the way you can, let's say, convert the problem into the work done, and total work done of the system is 0, and that's how you will calculate the reactions. Okay. Let me give you another simple question. Yeah, maybe this one you try to solve with the virtual work. Yes, Abhishek, you can assume it as a clockwise moment as well. Okay, it's a problem. Okay, Abhishek. So if you rotate it clockwise, what will happen? RC will be upward, but your YC will be downward. So you can say, in that case, equation will look something like this: minus RC into YC, and XA will be in the direction of 10. So plus 10 into XA equal to 0. This is how your equation will look like, Abhishek. Is it clear? And ultimately, you put this value, you should get the RC is equal. Okay. Yeah, Sandeep, you can ask your doubt. You have raised your hand. Feel free to ask your doubt. You can unmute and ask.
Yes, sir. Same question I was asking. You got after that. That's why I was saying to come back.
Okay. Yes, no problem.
Okay, sir.
So yeah, in any direction you can take. It's your choice. Okay. Maybe I will explain once again through this figure as well. So here we will rotate it clockwise as well as counterclockwise, so you will feel comfortable. But I would suggest you to not to use this method in your GATE exam, and use
So
only
one
the
second.
equation of
So,
equilibrium.
previous
Yeah.
question I did not write, sir.
Okay. I'll wait for 2 minutes. You can write and just put a message in the group once you are done. Okay, fine. Then take a next question. We have one, let's say, in support, and at other end we have the roller support. Okay, let's call this point as E. Here we have point B, where here B, and then we have point C. And at point B, we are applying a load of 10 kilonewton. Point B is kept at 2 meter distance from A, and C is at 3 meters distance from point B. Okay. So the question here is calculate RC. So if you want to use the equation of equilibrium, within a second you can answer it. 10 multiplied by 2 is equal to RC multiplied by 3. RC multiplied by 5, sorry. Hence RC will be equal to 4. That's all. Correct. But I want you to solve this question by virtual work because we are studying that concept. So imagine that this displacement, the displacement of the let's say the points A, B, C, either about point A. Let's consider about point A they are rotating because we are putting the constraint at point A. So imagine it like this, because at the point C can freely move. Okay, you can either do at point C, that's not a problem, but let's keep it at point A because we want to find the reaction at point C. I'll suggest you like this. Let me just draw the free body diagram first. Or the reactions here. RC will look like this, and this is AX, and this is AY. Why I'm doing like this, that the rotating this about the point A, because the unknown here is RC. That is what we have to calculate. Okay, if you want to calculate the reaction at A, then the other way around you can do. Okay, yes, like this. Fine. This is RC, and yeah. So this is a delta theta, is a small angle with which we are rotating this beam. Okay. Okay. Just a minute. Yeah. So I'll share again, and yeah. So now, let's say this is a displacement at point B. We can call it as YB, say, and here this is a YC is a displacement. Okay. B to B dash is YB, and C to C dash is YC. So what is YB displacement? YB here is delta theta into 2. So you can say 2 delta theta. Yeah. And what is YC here? It's 5 delta theta. Okay. And now, according to the principle of virtual work, total virtual work is equal to the 0. And how much is the total virtual work here? We have 10 into YB minus RC into YC equal to 0. We are considering this as a positive work, and we are considering this as a negative work because of the direction of the force and the displacement direction. If it is same, we'll consider it as positive. If it is opposite, we consider it as a negative. So from this, what we will get is 10 times YB is equal to RC times YC. So what is YB? YB is 2 times delta theta, and YC is 5 times delta theta. So delta theta will get cancelled. 20 divided by 5 is 4. So RC is equal to 4 kilonewton. Okay. So the problem you can solve either by equation of equilibrium or by virtual work. Okay. So it's more or less same, but yeah, generally I would suggest you to use the normal equation of equilibrium, because this is making little bit complicated, adding little bit complexity to the problem. Okay, and will take your more time. Okay. So this problem is useful everywhere. It's not like this is an alternative way. You might have studied, let's say, vibration topic, and in vibration topic you are creating the equation of motion, not just because with one method, but you can use multiple methods to solve it, right? And that's what we'll study again in the Lagrange equation as well, okay, when I come to there. um, so it's an alternative method. I would not say it's like um, in this case of problems you should use this, and other set you should use it. it's um, it's not like that. It's an alternative method you can use for any problem. Either the principle of virtual work, the actually the concept or methodology which they are using, or approach which they are using, is the work approach. That is the total work, let's say, done by the system, when if it is in equilibrium, is zero. And that is the approach this concept is having. And the the initial concept, that is equilibrium concept, is that summation of all the forces and moments when body is in equilibrium is zero. Okay, so these two are parallel approaches, and both are equally equal. So both are correct. You should not, let's say, distinguish between them. But comparatively, if I feel, or most of the people feel, that um, the approach of uh, equation of equilibrium is quite easier, and with less time you will be able to quickly answer the problem, okay, compared to the virtual work. So it is still useful, but yeah, you should be um, aware that it's not specifically that you should, in this kind of set of problems you will use this, and in other set you will use the different one, okay. So it's nothing like that. Okay, so that's all we have from the mm, principle of virtual work. Okay, so you can take some questions whichever you want, which we have studied in statics, and try to solve it if you want. Otherwise I'll give one homework question to you which you can try later. Okay, this is the system, and in this problem as well, okay, Sanjeev and Abhishek, you can rotate it in this counterclockwise direction as well. Okay, it's not necessarily that it is to be in downward direction. It's your choice. You can, let's say, rotate it in counterclockwise direction by delta theta. It's equally correct. So here, this problem I'll give A, B is the beam. Okay, simply supported beam, and then we have 10 Newton force. Then we have 20 Newton force. This is 2 meter distance. This is 1 meter distance, and this is again 1 meter distance. Okay, total is the 4 meter distance. What you have to calculate is VA and VB. Okay, both of them you have to calculate, and try to calculate by using principle of virtual work. Okay, I'll give the answers. VA is 17.5 Newton, and this is 12.7 Newton. You can easily calculate by equation of equilibrium, by taking moments and summation of vertical forces equal to 0. But I want you to try this problem with the principle of virtual work. Okay, and if you face any difficulty, feel free to reach out to me. I can help you with the answer. Okay, so take this for your homework. Yes, Abhishek, I'll share you the question bank. So what happened is, we are taking a lot of uh, problem solving session. You might have observed, like, majority of the classes are focused on the problems, because we have very less theory in the mechanics, and we have to understand the theory from the problems itself. There is, like, concepts are very very small, but when we study variety of problems, their application is little bit different, and you should know how to deal with the variety of problem. That is the reason we focused on problems. So I have some set of problems, but yeah, I will give you, let's say, through WhatsApp, on, let's say, weekly basis, and you can work over there. Okay, so that's how we can do. Yeah. Okay. Write down next heading: Lagrange's equation. Lagrange equation. Okay. Again, we are studying it at the end. Why? Because it's not the only method um, to use in the kinetics in order to generate the equation of motion. Okay, when you will study the vibrations topic, you will understand how to create the equation of motion. Okay, and there are variety of methods to create the equation of motion. So for example, potential energy equal to kinetic energy you will do, or sum of all the energy equal to zero, or you will use the equilibrium method. So couple of methods are there which will help you to generate the equation of motion for the system. Okay, and yeah, and what we use is we use the D'Alembert's principle, right? We use D'Alembert's principle to generate the um, equation of motion and solve it. Okay, so for example, let's say um, we have or let me just introduce it like this. In mechanics, either you can use this approach of Newtonian approach, Newtonian approach, or Lagrangian approach. Okay, so what is the difference in between them? We know in Newtonian approach how it works. It works on summation of the forces is equal to mass times acceleration, and then you applied ma as an let's say imaginary force or inertia force opposite to the direction of motion and solve the problems. Okay, so we have generated the free body diagram of it, and then we calculate the forces on it, and then applied the dynamic equilibrium considering this equation. Correct, that is what we have done in the Newtonian approach, which works on which is D'Alembert's principle, which we say. Okay, or even let's say work energy principle also we studied. There also we calculated the free body diagram, forces, and then um, we have applied the work energy principle. But how this Lagrangian approach works? It is based on the energy formulation. Um, energy formulation, and it is it looks like this. Maybe I'll go to the next slide and say um, Lagrangian method is revolving around a parameter called as L. Okay, and you can call it as Lagrangian. So L is equal to which L means Lagrangian. Okay, the variable L is Lagrangian, and that is the difference between the kinetic energy minus potential energy. Okay, kinetic energy minus potential energy. Uh, so what is this L, T, Q, and all we will see, and how it will help to calculate the, or how it will help to generate the equation of motion. That is the main question. Okay, so what is this L? L is Lagrangian, and it is the function of L is the function of Q, Q dot, and T. Okay, then what is this new Q, Q dot T we know, T is time. And what is this Q and Q dot? Q is any generalized coordinate. Okay, generalized coordinates, you can say. It can be X, it can be Y, it can be Z, theta, anything. Okay, etc. Okay, so in linear system, it will be X, Y, Z. What is Q dot? Is generalized velocity, you can say, because uh, differentiation of displacement with respect to time is Q dot is differentiation of Q with respect to time, and you can say it as a velocity. So it's a generalized velocity. Velocity. And what is T? T is the time. So what we can say is L is function of Q, Q dot and T. It means indirectly L is the function of X, Y, Z, X dot, Y dot and Z dot and T. Okay. Uh, and how this L will help us in order to generate the equation of motion is d by dt, or let me go to the next slide, d by dt of dou L by dou Q minus dou L by dou Q, and here dou L by dou Q dot, okay, equal to 0. So this is the equation of motion, or you can say it as a Lagrangian equation. Let's call it as Lagrangian equation.
Screenshot.
Yes.
Sir, previous page, sir. Sir, you are very fast, sir. You are changing the page very
Yeah.
fastly,
Okay.
sir.
I'll go. I'll go to the previous slide. I'm just writing the stuff first, and then I will.
Okay, sir.
I'll yeah, because I just want to first follow it, and then you can write it. Okay. Because this might be a new topic for most of you, and it is recently added to the gate from last 2 years. Previously it was not there. I'm not sure whether you have studied in your syllabus, because it is also like same. Some of you might have studied it in vibrations topic, and I'll say like it's not again the compulsory. It is an alternative method to what we have studied. Okay, so the problems which we have studied before, the same problems we'll be studying here, but with the Lagrangian approach of solving it. Okay. Mm. I'll come back to the previous slides. Just give me 1 or 2 more minutes to explain a little bit, and then I will start. I'll give some time for you to write the stuff. Okay. So this is an Lagrangian equation where L is the Lagrangian, and Q and Q dot are the generalized coordinate and the velocity. Okay. T is the time here. So this is how you will generate the equation of motion. So this Lagrangian equation will give you, this is nothing but the equation of motion. It will give us the equation of motion for the system. So you can imagine like how complex it is, because you have to first calculate L. L is the um, uh, L is the difference between kinetic energy and potential energy. So you have to first calculate the kinetic energy, then you have to calculate the potential energy, then take a subtraction of it, and then take a differentiation of it with respect to Q, with respect to Q dot, and with respect to again with respect to T, and put into this equation, and then you will get the equation of motion. Okay, so yeah, little bit tedious compared to what we have studied in the D'Alemberts and all. Okay. So write down from beginning now. I hope you are done with this first slide. I have just explained you what is what are the two different approaches. One is the Newtonian approach based on the summation of forces equal to mass times acceleration, whereas the Lagrangian approach, as I said, consisting mainly based on the kinetic energy and potential energy. Okay, and Lagrangian L is equal to kinetic energy minus potential energy. Okay, so difference between them is L. And here I'm explaining how it is related to um, the L is a function of what? L is function of um, x, y, z, x dot, y dot, z dot, and t. Okay. Let me know once you're done with this slide. Yeah, okay. You can also write down the next equation like this. This equation is for the conservative force system. Conservative force system. Okay, and the same equation will look like this: d by dt, dl by dq dot minus dl by dq, sorry, dou L by dou Q equal to F non-conservative. And so this equation is for the non-conservative force system. Okay, this is for non-conservative force system. So what is non-for conservative force system and what is conservative force system? The force where work done is independent of path but depends on initial and final positions only, that we call it as a conservative force system. So for example, the gravity force or spring force, tension in the string, etc., are considered as a conservative force system. And non-conservative forces included means, for example, the um, fluid friction or normal friction or air drag in the system. All these, if you want to consider it in the problem, then it belongs to a non-conservative uh, force system problem, and in that case the second equation you will be using. Okay, but as of now we will focus only on the conservative force system, where we'll not be considering this drag or fluid friction. Okay. So this is just for your information, that um, if you consider the frictions and all, then um, it will look like this. Okay. Yes, Nishant, we will be solving questions on this. I just am explaining you theory part. So once it is done, we will go towards the problem. Okay, are you done with this slide? Okay, so let's start with some simple questions first. So for example, if I give you equation, a ball is there which is freely falling downward. Yeah. And if I ask you to say calculate the equation of motion in this case, how it will look like? How it will look like? Um, or let's say, so we have a ball of mass m freely falling downwards. No, so, or let's see how the acceleration will look like in this case. What will be the acceleration in this case? Yeah, it is g. So it's a freely falling up object. Mg will be the weight acting downward, and inertia force will be mass times acceleration. You can easily say the acceleration in this case is just only the acceleration due to gravity. Okay, but you're not applying the Newtonian approach here. You want to approach the Lagrangian approach. Okay, um, you have to apply the Lagrangian approach. So you will first calculate the coordinates in this case. So in this case, the moment is along y direction. So the q, as I said, is the what was the q? Q was the um, dimensions, right? Okay, generalized coordinates you can say, and here that coordinate is y. So q is y in this case, and q dot will be y dot. So that is the velocity in the y direction. Okay, so let's consider this as a y-axis and this as x-axis. So our motion is only in the y direction. Okay, so our focus will be only on the y coordinate. How the kinetic energy will look like? T is kinetic energy. Half mv square is the kinetic energy. So it will look like as half my dot square. Is it correct? How the potential energy will look like? Mgh, right? Mgh, and that will be equal to mgy. Okay, and how the Lagrange will look like Lagrangian parameter? That will be equal to t minus u. So it is half of m y dot square minus mgy. Is it clear till this? So L will be equal to half my dot square minus mgy. Let me go to the next slide to solve it further. Okay, or before that you can write it down and let me know once you are done with this slide. Are you done with this slide? Yeah, okay. So what was the L? 1/2 m y dot square minus mgy. And what is our equation of motion? If you remember, d by dt of dou L by dou q dot minus dou L by dou q is equal to 0. Okay, this is our equation of motion. So calculate these derivatives and put it into this equation. Calculate the derivatives. So how the dou L by dou q will look like? It will be minus mg, because dou L by dou q means it is dou L by dou y. Q is y in this case. Similarly, dou L by dou q dot is dou L by dou y dot. With respect to y dot, we have to differentiate it, and it will be 2 will get cancelled. You will get only my dot. Basically, 1/2 as it is, m as it is. Differentiation of y dot square is 2y dot. Okay, 2 will get cancelled, and it is my dot. Is it clear till this? And then d by dt of dou L by dou q dot is differentiation of what we have just calculated with respect to t, which is my double dot. Okay, so my double dot plus mg equal to 0 is the equation of motion. Because yeah, just put it in back into this. This is this parameter, and this is this parameter. Okay, and the equation of motion will look like this. mm will get cancelled. Y double dot is equal to minus g. So it means acceleration is minus g because the negative sign indicates it is in downward direction. Indicates the downward direction. Okay, any doubt in this question? Is it clear to you all? So this is a simple situation I have given, but yeah, maybe this you will understand it more better when you study the um, vibrations topic. Okay, because in vibrations topic you have to prepare the equation of motion. Okay, in mechanics problem, like if you just want to calculate the, let's say, acceleration or the force or the displacement, velocity and all, you don't need let's say to have, let's say, complete equation of motion, and then because you have the approaches, other approaches to solve it. For example, D'Alembert's principle, it also does the same actually, but yeah, comparatively simpler than this, um, and should be it should be able to solve it with that as well. Okay, um, so yeah, we got question from Abhishek, in which type of problem we should go for Lagrangian. I would say maybe in the problems which are mainly related to the vibrations. Okay, for example, you have a spring mass kind of system. Okay, in that case you can go for this, Abhishek. Okay, because um, the spring will have some potential energy in it, and mass will have some, let's say, kinetic energy, and then you can uh, take a difference of it and solve the problem. Okay, uh, I'm sure that maybe whoever will be teaching you vibrations, they will again introduce this topic to you there, so you will be aware of it mm, during vibration. But anyway, I will take an example here of a spring mass system so that it will be clear to you all. So in such kind of situations, you can go for the um, this equation, the Lagrangian method. Sanjeev Kumar, for the single degree of freedom systems, like, yeah, you can do it. Even for 2 degree of freedom system, like where, let's say, more than two variables are there also you can use this method. Okay, it's not like, yeah, you should restrict it for the single degree of freedom system. Um, you can use this method for 2 degree of freedom system as well. Okay, it's your choice which you want to use, um, whenever which you feel better, because I I think whenever you study this topic vibration, um, the the teacher will introduce you the methods which you can use to um, generate the equation of motion. Okay, so as what I think is the equation of this Lagrange equation, you can use it from mechanics point of view. I would say is like whenever a spring mass kind of system is there, in that cases it will be better if you apply this method. Okay, but in rest of the all cases, I would suggest you to just go for the D'Alembert's and work energy principle. Don't even try for this method. It will unnecessarily take your more time. Okay, it's an still I would say it is an optional. It is not necessary that you should solve the problem with this. Okay, it comes with some additional complexity and more time. Okay, but yeah, as I see, most of you are, let's say, in both aero guys and meg guys will have vibration topic, right? So you are aware of equation of motion and vibration. So maybe in those kind of problems you can apply this method whenever you get a spring mass kind of system and they ask you to generate of equation of motion, or they'll ask you to calculate the um, natural frequency, right? In those situations you can apply this method. Okay, let me give one simple example. We have a spring and mass. Okay, have you studied vibrations topic, or it is yet to start for you? Okay, no problem. So yeah, I hope, but you might have seen this kind of figure at least during your engineering, okay, first year or second year maybe. Okay, this is how a spring mass system will look like, and let's say this is the displacement x. Let's call it here somewhere x is the displacement. Now here generalized coordinate is x, q dot is x dot. So in this case, if I ask you to calculate the equation of motion, how it will look like, in simple word, mx double dot plus kx equal to 0, right? This is how it will look like. You can you might have studied this kind of equation before, mx double dot plus kx equal to 0. So it's a equation of motion when you don't have any damper in the system, because you don't have, yeah, here damper is not attached, so that term we are not putting into the equation, and it's a free vibration because we are not having showing any force here, so that's why equal to 0 we have in the right hand side. It's a typical equation of motion, simple harmonic motion, where we don't have any damping, and it's a free vibration. So how will you generate this equation by this Lagrangian method? Is you will first calculate the kinetic energy T, that is 1/2 mv square. V is x dot here, so x dot square. Kinetic energy is that, potential energy is U, half of kx square. This is the potential energy of the spring with a spring constant k, stiffness k. Okay, stiffness is k here, half kx square. So the Lagrangian L can be written as T minus U, which is equal to 1/2 mx dot square minus 1/2 kx square. Okay, so this is your L. Okay, so how dou L by dou x will look like? It will be minus kx. How dou L by dou x dot will look like? It will be how much? Mx dot. And how the d by dt of dou L by dou x dot will look like? Yeah, it will be mx double dot. Okay, so if you put into the equation of motion, what is the equation of motion? Dou by dou t of dou L by dou x dot minus dou L by dou x equal to 0. In this equation, if you put, you will get mx double dot plus kx, minus minus will become plus, equal to 0, and this is what I have already written before. This is the equation of motion. Okay, you can still solve the problem by using D'Alembert's principle. Okay, that's not you can still solve it by D'Alembert's principle, and because mx double dot will be the imaginary force there, and kx will be the spring force, so ultimately you will end up with the same equation. Okay, so when you study mechanics, this question will be your basic first. When you study the vibration, this will be your first basic problem, where you will generate this equation not just by D'Alembert's principle, but also by Lagrangian method, and I think one more method will be there. I think total 3 methods are there to generate this. Okay, we have studied D'Alembert's principle before, and now this Lagrangian method is just an alternative to it. So now x double dot is equal to k by m, x equal to 0, and you know this k by m is omega square, and omega is root of k by m, that is your natural frequency. Okay, so yeah, so in this kind of problems, I would say you can use the equation of Lagrangian equation. Okay, so this is your second order equation. You can solve it to calculate the displacement. It's an homogeneous differential equation. The complementary function will be the solution for it if you want to calculate the displacement. Okay, yeah, so this is this is how the method will look like. Okay, any doubt in this Lagrangian method or Lagrange equation? Is it clear to you all? So the approach is only different. Things are more or less same. This is mainly used to generate the equation of motion. Okay, and you will use this in the vibrations mainly. Okay, uh, not specifically in the mechanics to calculate the forces and moments. Okay, we need the equation of motion in order to calculate the natural frequencies, displacement, amplitude, and in those situations um, I would suggest like you can use this. Okay, let me give you some more questions so things will be clear to you. Okay, uh, just a minute. So basically, yeah, yeah, this is how acceleration will look like here. In the second question, I'll give one more question to you. You try to generate the equation of motion in this case. Okay, take a simple pendulum. Okay, it's rotated with angle theta, and L is the length. This is L times 1 minus cos of theta, and m is the mass of this ball. Okay, can you tell me how the equation of motion will look like for the simple pendulum of mass m attached to a massless string? You might have studied this equation before during class 12th or first year maybe. So theta double dot plus g by L theta equal to 0. Have you seen this equation before? Natural frequency of simple pendulum you might have studied, right? Omega is r root g by L. Yes. So how it is calculated? It's calculated based on this equation of motion. And how this equation of motion is generated? Yeah, by different methods you can generate, and one of the method is this. Either you can use D'Alembert's principle or you can use the energy method in this. So so as of now we are studying energy method, so focus on it. Calculate Lagrange parameter, which is T minus V, and solve it. Yes, Sanjeev, that method is also correct. Kinetic energy plus potential energy is constant, and differentiation of the total is equal to 0. So yes, you are also correct. That is what we have studied in work energy principle, right? That mm, what is this is, let's say, total energy, kinetic energy plus potential energy at some location, and kinetic energy plus potential energies at some other location. It is same basically, right? So it is energy changing from one form to other. So if it is remaining constant, then its differentiation with respect to time is zero. So that approach also you can use in order to generate the equation of motion. You will study this in vibration. Okay. um, yeah. So as of now, I want you to solve it by Lagrangian equation, since it's part of our syllabus. So what is kinetic energy here? Is half mv square. But what is velocity in this case? Velocity is what? V is equal to r omega. And what is r? R is L in this case. So L omega square, 1/2 m um, L square and 2 omega square. But what is omega? Theta dot square, you can say. Okay. Theta dot is, because your generalized coordinate here, q is theta and q dot is theta dot. So that is why I'm not writing omega. You should write it as theta dot square. Okay, half ml square, theta dot square is your T. Kinetic energy. Potential energy V will look like as um, mg h. H here is mg L times 1 minus cos of theta. Okay. Okay, so like this you can calculate the kinetic energy and potential energy. Yes, Sanjeev, you can write kinetic energy as half I omega square, and I is equal to ml square in this case. So that method is also correct, or you can use this method, whichever you feel you want to use, you can use it. Okay. So here we are considering a massless string, so you should not consider anything mass of string and all, just consider the mass of the ball. So these are the two energies you will get, and how the L will look like. I'll go to the next slide to write L. 1/2 m L square theta dot square. And what is the potential energy? Minus mgl times 1 minus cos of theta. So if you simplify it, it will look like this: ml square theta dot square minus mgl plus mgl cos of theta. Okay, so this is L. Differentiation of L with respect to Q means what? Dou L by dou theta, and that is minus mgl sin theta. Correct? Differentiation of L with respect to theta dot is what? M L square. This half and 2 will get cancelled. Theta dot. And dou by dou d by dt of dou L by dou q dot is mls square theta double dot. Okay, so if you put it in the equation, d by dt of dou L by dou q dot plus dou L by dou q equal to 0. This is the equation of motion. ml square theta dot minus mgl, sorry, here it is minus, right? in the main equation. So here it will be minus minus plus mgl, and for smaller theta you can write it as sine theta equal to theta mls square theta double dot plus mgl theta equal to 0. M will get cancelled, 1 L will get cancelled. So theta double dot plus G by L times theta equal to 0. So this is equal to, if you compare with this equation, theta double dot plus omega n square theta equal to 0. So natural frequency of this is under root of G by L. Okay. Any doubt? Yes, I'll go to the previous slide. Write it down. I will wait for 2 minutes. You can write the things. Okay. Are you done with this slide? Yeah, okay. Yeah, you can write the second slide as well and let me know once it is done. Done. Okay. Is it done? The slide as well? I'll give you one more question and I want you to solve it and tell me the answer of or create the equation of motion. Okay. Take this system. Pulley system, you know, we have solved this kind of problem a lot. M1, M2 are the two different masses, and from the datum, let's say they are kept at distance of y1 and y2. Okay, and at this moment, this is how it will look like. R is the radius of the pulley. Ignore the, so assume it as massless and frictionless pulley. Okay, with this assumption, try to create the equation of motion for this problem. Okay, yeah. Okay, or how you will calculate the, let's say, acceleration of first y1 double dot you want to calculate. Okay, so how to calculate y1 double dot or acceleration, or how you will write the equation of motion. Both are like same things. So you can create the equation of motion for this. Okay, I'll give you 2-3 minutes. Try to spend some time and solve it. spend some time on it and post your answer. I have given you the y1 and y2 displacements. You can find a relationship between them. Say y1 plus y2 is equal to constant. Okay, because if y1 is increasing, y2 will decrease. Y2 is increasing, y1 will reduce. But ultimately, the total sum is constant. So how you'll write y1 or how will you write y2 equal to c minus y1. So y2 dot will be equal to minus times y1 dot. Okay, so this is how the coordinates will look like. Now you can work on the kinetic energy and potential energy. T is the kinetic energy, how the kinetic energy will look like. There are two different masses. They'll come up with the two different kinetic energies. 1/2 m y1 dot square plus 1/2 m2 m1 y1 dot square m2 y2 dot square. And we just found one relationship between y1 dot and y2 dot, that is y2 dot is equal to minus y1 dot, but its square will be again positive. 1/2 m1 y1 dot square plus 1/2 m2 y1 dot square. So it is 1/2 m1 plus m2 y1 dot square. So this is the kinetic energy. How the potential energy will look like: mgy1 plus m1g1 m1gy1 and m2gy2. m1gy1 plus m2g c minus y1. Okay, we got one question here. There is a negative sign n. Where is the negative sign? It's a square, right? So square, if you take of negative number, that will be positive. Why it is negative, Nishant? Why you are saying it as negative? We are not considering the approach of Lagrangian to draw the. We are not considering the approach of this forces to calculate free body diagrams and apply the tensions and all. Okay, we are considering the energy approach. We are calculating the kinetic energy of the system and the potential energy of the system. Yes, why that is that I agree. That y1 is equal to c minus y2 is equal to c minus y1, and y2 dot is equal to minus y1 dot. Yes, but its square will be positive. Yeah, okay, that's why see y2 dot square will be minus y1 dot square, right? And what is minus square is again positive, right? y1 dot square, and that's why I have not written that sign here. Okay, coming towards, yeah, here I'll write the negative sign because it is not the square. y2 I am writing as c minus y1. So m1g y1 plus m2g c minus m2g y1. Okay, this is your potential energy. So write till this and then let me know once you are done. so that I can calculate Lagrangian and then the equation of motion. Have you solved it? Okay, I'll go to the next slide and help you. L is written as T minus U, and that is 1/2 m1 plus m2 y1 dot square minus mg y1 minus, sorry, this is m1g y1 m2g c plus m2g y1. Okay, signs are changed because we have minus n here, T minus U. Now again you have to differentiation of Lagrangian with respect to Q, and that is dou L by dou y1, and that is equal to how much? So only this term will come first, this and this. So minus m1g plus m2g. So you can say m2 minus m1 times g. Okay, then dou L by dou Q dot will be equal to dou L by dou y1 dot, and that is again 1/2 into m1 plus m2 into 2 times y1 dot. Okay, so 2 will get cancelled. Again m1 plus m2 times y1 dot, m1 plus m2 times y1 dot. So if you put it into the equation, or let's differentiate this again with respect to t, that is equal to m1 plus m2 y1 double dot. Okay, so now if you put it into the equation, what is our equation? D by dt of dou L by dou Q dot plus dou L by dou Q equal to 0. This is our equation of Lagrangian equation basically, which gives us the equation of motion. So how it will look like is m1 plus m2 y1 double dot, sorry, minus sign here, minus m2 minus m1 times g equal to 0. Okay, so y1 double dot is equal to m2 minus m1 divided by m1 plus m2 times g. Okay, so this is how the answer will look like. Okay, is it clear? This is how you'll calculate the acceleration. Okay, Pranjul, the sign I think you got is plus. It
Last
should be
slide.
minus. Yep, corrected. Yes,
The
I'll go to
last
the
slide.
previous. Yeah, I'll go.
Thank you.
So, so as you can see, in majority of the question, what we are doing is calculating the equation of equilibrium, equation of motion in this case, and that will help you to calculate the natural frequencies or how the acceleration will look like, and then you can solve it to get the displacement by using the mathematics, that is complementary function and all. Okay, so yeah, I would suggest whenever you have the vibration related topics, so whenever a system is consisting of dampers, the system is consisting of springs and all, better you should try this method. Otherwise, if normal question comes, I would suggest you to go ahead with the traditional methods which we have been using in the Newtonian approach, which are mainly focused on forces and um, free body diagram. Okay, that is comparatively easy, and we have been studying during our engineering that the same thing. So you are more habituated it, and comparatively they are simpler. Okay, so in order to calculate the acceleration, if I give you this problem, you can easily calculate with free body diagrams and applying the equations of dynamic equilibrium to it, right? But now if you are using this Lagrangian approach, it takes little time. You have to first calculate kinetic energy, potential energy, put it into L, differentiate it, put back again in the formula. So a lot of steps are involved in it, and it is little time consuming. Okay, and whenever question comes in gate, they are not asking you the method which specifically that you have to solve with this particular method. They are simply asking you the question, and you have to apply whichever method you feel. So normal questions, I would suggest majority of the questions should be done with the normal Newtonian approach. You should not use Lagrangian approach. Only maybe in vibration topics you will study it when you study that subject. In those situations, this concept is helpful. Okay, but now I hope you are aware of it, the process to calculate the or generate the equation of motion. Is there any doubt in these two topics, virtual work and um, Lagrangian equation? Both are optional topics. Okay, they are not, let's say, a compulsory topic or compulsory methods to solve the problems. That is the reason we kept it at then, because they will not affect the overall understanding of the topic. They are just an alternative methods to solve the problems. Okay, is it clear till this? Anyone have any doubt? No doubt. Okay, because I don't have much things today apart from this, so maybe yeah, we can close it early today, and in the next session I will come up with the, it will be a practice session. Okay, I'll bring problems from the statics part mainly, and some from the dynamics part, because we have solved a lot of recent recently we have solved many problems in dynamics. I'll try to bring more from the statics, so it will be a mix of it. And in the next session, in the Saturday session, we will solve it. Okay, you can join it because it will be mainly your participation in that. Okay, so that's all for today. And yeah, syllabus is completed for you. With this, you should be able to solve the problems. Okay, just you need the practice and touch with this subject. So you are studying this subject in the Feb and March. Okay, and we have like exam in next year Feb. So don't just do it now and forget it afterwards. So revise it again after few months. Okay, once you, let's say, feel lot of time has been passed, after let's say 3-4 months, revise this subject shortly. No need to, let's say, watch complete recording from beginning till end. You can just go through the PPTs, you will be able to understand. Okay, um, and that will help you to understand this subject. Okay, the nowadays the gate exam is not like a conceptual exam where, let's say, very brilliant students score the marks. These days, like, competition is a lot, and for a single, let's say, 1 or 2 marks, your rank will vary a lot. So I would suggest you to practice as much as possible, because even if you know the concept, if you don't do a practice, you will not be able to, let's say, manage your time during an exam. And even if you are capable, you will miss the chance. Okay, so this is the main thing I'm suggesting you, because in gate exam, you have to be not just talented, but you should be smart enough or fast enough, so that you will cover majority of the paper before time, and spend some time on the analysis of it. Let's say if you have some questions which you think you will do at 10, uh, you can focus on those questions. Also, let's say you can cross verify your answers, because you have, let's say, done a question, but you feel that it may be correct, may not be correct. But at the end, if you save your, let's say, half an hour or 20 minutes time, you can use it for these purposes. Okay, so, and you can save your 30 minutes of time in exam only if you are habituated with solving the problems, or doing practice. Okay, so you do practice a lot, you will be able to solve the problems fastly, and then you can save time for each question. And then you will realize that you are able to, let's say, save close to half an hour and complete majority of your paper within 2.5 hours. And then that 30 minutes you can use focusing on some questions. Yeah, obviously there will be some very difficult questions, and you will not be able to solve it. And some of you will not be able to solve it. Then it's fine, you may not necessary that you should solve each and every question, but whatever questions you are solving, those should be accurate enough. And you can use this time there, making sure that you are whatever you are answering, if you are answering all questions, that is perfect. But if you save some time, you can just check them again, and if there are any silly mistakes, you can actually save or get very good marks. Because even if you find 1 or 2 silly mistakes in your overall paper, that will give you like close to 4 marks, and it will change your rank by thousands. Okay, yes, apart from this subject, um, I'm not sure for your batch they will give me any other subject, um, but yeah, I will be teaching mathematics for some of you. Not sure for your batch. Maybe if it is started, then for different batch I'll be teaching mathematics. But yeah, that's all. That this is the only topic I'll be teaching for Aero. If mathematics is already started for you, then I think yeah, I don't think any other subjects I'll be teaching you, but it's not a problem. You can reach me on WhatsApp. I have given you my WhatsApp number, not just for the subject related stuff, but if you have any issues in preparation, um, if you're thinking like you are lagging in confidence, you can feel free to reach out to me. Okay, it's not a problem. We can talk and try to resolve it. Okay, and it's good that all of you have joined this institute very in early phase. You have 1 year, complete 1 year for your preparation, and that is very good decision you have taken, and you are already ahead of majority of your competition. Because when I started preparation, I started it in the July. Okay, so you are, so comparatively I feel like you are doing great job here, and by starting your preparation from February itself. So that is very strong point for you. But just remember that as month passes, there is a chance that you will forget some things, and so try to keep your concentration by revising the topics regularly. Okay, so at least once or twice you should revise the complete syllabus during your this 1 year time frame, and spend as many as possible months on just practicing and solving previous year papers. Okay, um, that is my suggestion to you. Yes, I did post graduation from IIT Delhi, and in in the similar branch. Okay, yeah, and yeah, I so the way I studied is like I started in July, and July till November I spent time in studying the subject. Okay, and then the last 2 months, the December and January, I focused mainly on the previous year question papers, mock test papers, or online test series. Because, and I felt that the last 2 months were the most important ones, because though that time gave me a clear understanding of the exam pattern, how I will manage the time during my exam, and uh, how can I avoid my silly mistakes. Okay, everyone does the mistake, so keep this in mind that you should be fast enough, because these days a lot of students are um, giving this exam, and later you should not let's say regret that uh, if I get 1 or 2 more marks, I would have got this college or this PSU. Okay, so you have enough time for it. Just do practice a lot, because talent plus hard work is really needed for this exam these days. Okay, previously the competition was less. Hard work, if someone is not doing a lot of hard work, that's fine. He was like able to get to some certain level, but these days many students are appearing this exam, so I would suggest don't take it casually. Okay, if you do a bit more hard work than what you are doing now, I will promise you it will give you few more marks, and it will increase your rank by thousands. Okay, so keep this in mind. Okay, so thank you all for joining this session, and we will be in touch um, even after the completion of your syllabus, and we'll meet again on Saturday with the problem solving session. So thank you all. Bye. Good night.